Okay, we derived a recursive definition for all pairs shortest path, and the resulting algorithm is called the Floyd-Warshall algorithm. And here it is, right? We essentially take the recursive definition we had derived and just turn it into a standard dynamic program. The dynamic program is very simple how to do it because we know that as we go from k, in the recursive call, we are always calling on k minus 1. So filling is easy. K is going to be in the outer loop. Now, first we have to fill up the table. So the table, the dij0. So dij0, to remind you, is just the length of the edges between vertex I and vertex j. If there is no edge between I and j, we set the price to infinity, right? So we fill up this table. And now what we do is that we just go layer by layer, k equal 1 to n. And for each one, for each I and j, we just compute dijk using the definition. Clearly, we have 3 loops. Each one takes n time, so it's going to be n cubed. This is the innermost part is constant time, so this is n cubed time. And then all we need to check is whether there is a path from a vertex to itself with price smaller than 0. If it happens, then there are negative cycles, and we are done. This is the algorithm. It's pretty simple. And its running time is n cubed instead of the n to the 4th, which followed from using Bellman-Ford n times. So it's a very nice improvement, and the algorithm is surprisingly simple despite its bizarreness. Okay. Now, if we want to find the paths themselves, we need to be a bit more careful. So what we are going to do is we are going to remember when we have the path between I and j, we are going to remember the middle vertex that we used to update the distance between I and j, right? Because that's all we really need to know. So this is how it's going to look like. We're going to have this next ij. Next ij is really a misdemeanor. It should be mid ij, right? This is the middle vertex between ij. So we remember whenever we update the distance ijk, using vertex k, we put next ij to sk, right? And now we have all the information we need, right? Because once we compute the table, because, whenever we want to compute the distance between I and j, the table would tell us, oh, you use the kth vertex as a middle vertex, so we will recursively compute the path from I to k. Again, I to k would tell us which middle vertex to take and so on. And then from k to j, the same thing, right? So to extract all those shortest paths, you need only O of n square space, which is kind of magical, right? Because the total length of the path is much bigger than n square, but you need to remember essentially only one number for every shortest path. And then the recursive definition take care of things. Okay, so make sure that you figure out how to extract the shortest path if you need it from this table. I kind of sketched it, but verify that you really understand the details of how it's being done. Okay, so this is the Floyd-Warshall algorithm.